Hey there, friends. Welcome back to Electricity Frenzy, your go-to spot for electrifying content. Today, we're diving into a question that zaps into the mind of many DIers and electrical enthusiasts. What happens if you run a motor on the wrong voltage? Buckle up, because we're about to spark up some knowledge. First off, it's crucial to understand that motors are designed to operate within a specific voltage range. This isn't just a suggestion from the manufacturer, it's like the secret recipe for the motor's best performance. Now, let's break down what happens when we mess with that recipe by using the wrong voltage. And trust me, it's more than just a minor hiccup. Scenario 1, running a motor on a voltage that's higher than it's designed for. The extra voltage makes it overheat. The insulation on the wires isn't meant for that kind of party. It breaks down, leading to short circuits or even a total burnout. Not exactly what we want, right? Not the best way to treat your motor. Now, let's flip the switch and see the other side. Scenario 2, what if the voltage is too low? Well, it's like trying to jog through molasses. The motor draws more current to make up for the lack of voltage, overheating in the process. This extra current can damage the windings over time, leading to a reduced lifespan of the motor. So, running a motor on too low a voltage? Also a bad idea. So, what's the takeaway here, folks? Voltage matters, a lot. Using the wrong voltage can lead to inefficiency, damage, and even dangerous situations. Always check the motor's voltage rating before you power it up. And if you're ever in doubt, consult with a professional. It's better to be safe than sorry, especially when it comes to electricity. The question now is what to do if your motor voltage is not the same as your outlet voltage? Now, here's where transformers enter the scene, not the robots, folks, but the electrical kind that can save the day. A transformer can step down the 220 volts to a more manageable 110 volts, ensuring your motor runs smoothly without any hiccups. But, and it's a big but, you've got to pick the right transformer. It's all about the power rating, my friends. The power of the transformer must be higher than the power of the motor. Why? Well, if the motor demands more power than the transformer can handle, the transformer itself becomes the weakest link. It'll start to overheat as it struggles to keep up with the motor's thirst for energy. And just like the motor, if the transformer gets too hot, it's game over. It can burn out, not to mention posing a serious fire risk. Think of it like this, your transformer is like a bridge over the 220 volts rapids. If the bridge isn't strong enough to handle the weight crossing over it, it's going to collapse. So, making sure your transformer has a higher power rating than your motor is like building a bridge strong enough to handle a fully loaded truck. It ensures that everything flows smoothly from one side to the other, without any breakdowns. So, folks, the moral of the story is this: respect the power of electricity and equip yourself with the right tools for the job. A transformer isn't just a handy gadget, it's a safeguard between your precious 110 volts motor and the mighty 220 volts power supply. But remember, it's got to have the muscle to handle the load, or you're setting the stage for a not so electrifying drama. Power pioneers. Guess what? Simply matching the voltage isn't enough when it comes to running motors. Voltage is just one piece of the electric puzzle. There's another key player in town, and its name is frequency. Frequency, measured in Hertz, Hz, is essentially the heartbeat of your electrical system. In the US, the standard frequency is 60 Hz, but many places around the world use 50 Hz. Why does this matter, you ask? Let's find out. Just like voltage, your motor is designed to dance to a specific rhythm, or frequency. If your motor is tuned to the beats of 60 Hz and you plug it into a 50 Hz power supply, or vice versa, it's going to stumble. This mismatch can lead to lower efficiency, increased heat, and even damage over time, because the motor's not operating in its sweet spot. So, here's where things get interesting. If you have 110 volts motor and need to run it on a 220 volts outlet, even if you use a transformer to step down the voltage from 220 volts to 110 volts, if the frequency doesn't match, you're only solving half the problem. You need your beats to align, and for that, you might need a frequency converter instead of a voltage transformer. A frequency converter does exactly what its name suggests: it converts the power supply frequency and voltage to match the frequency and voltage your motor needs. This ensures your motor runs as intended, preserving its lifespan and efficiency. Think of it as translating a foreign language to your native tongue, making sure nothing gets lost in translation. But here's the kicker: frequency converters can be pricey and are typically used in more specialized applications. So, it's crucial to weigh the costs and benefits, especially for small projects or household appliances. Sometimes, it might be more practical to find equipment already suited to your local power supply's voltage and frequency. Here's a golden tip for you. If you're planning to purchase an appliance with a motor for use in another country, opt for a dual voltage model. Dual voltage, dual frequency appliances and motors. These motors are designed to operate on two different voltages and frequencies, typically 110 volts at 60 Hz and 220 volts at 60 Hz, although 50 Hz may also be a common frequency for such applications, especially in parts of the world outside North America. These motors have a special winding configuration that allows them to adapt to different electrical environments without losing efficiency or performance. This is particularly useful for machinery or appliances that are meant to be sold or used in multiple countries, where the standard household power supply can vary. The ability to operate on different voltages and frequencies is made possible by configuring the motor windings in such a way that they can be connected in series or parallel arrangements. For example, at 220 volts, or higher voltage, operation, the windings can be connected in series. This allows the motor to handle the higher voltage by distributing it across more winding turns, reducing the current through each winding and thus the overall current draw from the power supply. At 110 volts, or lower voltage, operation, the windings are connected in parallel. This effectively halves the voltage across each winding, since they share the total voltage, and allows the motor to operate efficiently at a lower voltage level. The switch between these configurations can be done manually by rewiring the motor connections according to the manufacturer's instructions or, in some cases, via an automatic switch that detects the input voltage. The frequency aspect, 60 Hz, or in other cases 50 Hz, relates to the speed at which the motor operates. The speed of an AC motor is typically tied to the frequency of the electricity supply. However, a motor designed to work efficiently at both 50 Hz and 60 Hz frequencies can handle slight variations in speed and performance without significant loss of efficiency or power. Adjustments for frequency differences are generally less about the wiring and more about the design of the motor itself to ensure it can operate within a range of frequencies effectively. Such motors are advantageous for portable tools, appliances, or equipment used in international settings, making them versatile for various markets without needing different models for each region's power standards. There you have it, my electrifying friends. The shocking truth about what happens when you run a motor on the wrong voltage. I hope this sparks some awareness and helps keep your projects running smoothly and safely. Don't forget to like, share, and subscribe for more electric content. Until next time, keep those currents flowing in the right direction. Before we wrap up today's electrifying journey, I've got a small, personal note to share with you all. Some of you might have noticed that I use AI voiceover in our videos. The reason? Well, I'm on a mission to improve my spoken English, and I want to ensure that nothing distracts from the accuracy and clarity of the information we share here on Electricity Frenzy. As an electrical engineer, my top priority is to provide you with content that's not just engaging but also precise and trustworthy. I'm here to spark curiosity and spread knowledge in the most effective way possible, and if that means using a little tech magic like AI voiceover for now, I'm all in. I truly appreciate your understanding and support as I work on my language skills. Your encouragement fuels my passion for electrical engineering and helps make this channel a space where learning and curiosity light up the dark. So, thank you from the bottom of my heart for sticking with us. Remember, friends, electricity is a powerful force, full of mysteries waiting to be unraveled. Together, we'll keep exploring, learning, and growing. Don't forget to hit that subscribe button and join us for more adventures in electricity. Stay safe, stay curious, and as always, keep that spark alive.